Hey everyone, my name is Mike,
And I'm Gavin.
and we are coming to you live from the Buhl Planetarium at Carnegie Science Center. We're glad you're joining us for Bite-Sized Buhl. Today, we're going to be looking up at our winter sky, and as we look to the constellations and some beautiful, colorful deep sky objects, they'll help teach us a little bit about the past, present, and future of our own star, the Sun. So to get things started, we are orbiting Earth, but we're going to land back in Pittsburgh and take a look at the sky. So let's come on in. You should see us zooming in, landing in Pittsburgh. We're using our Digistar 7 software to do this. It's the same software that drives the incredible universe engine of the Buhl Planetarium at the Science Center. But we'll give you a snippet of it right now. And as you're looking at the winter sky, you should see our friend Orion. Orion's a great guide to star hop to many things.
Orion in mythology was a great hunter, and he died when he stepped on Scorpius the Scorpion. To honor him, the gods put him in the sky. So, if we take a look at Orion, we see 3 stars about halfway down, and that is Orion's belt. And right below Orion's belt, we actually have a very interesting object. It is the Orion Nebula. So, this nebula is a stellar nursery. Stellar nurseries are dense clouds of gas and dust where stars form. The Orion Nebula is about 1,344 light years away and 24 light years across. And in these stellar nurseries, as I mentioned, stars forming. And so these stars form. As you can see here, there's lots of what looks like dust. And it is dust, it's gas and dust, and this gas and dust will get pulled together by gravity, and after enough after enough gas and dust is pulled together, it'll create a star.
Yeah, so we're going to take a quick maybe spin around the Orion Nebula. You can see lots of different colors. The reddish sections are hydrogen gas. That's a great view. The bluer areas, that's radiation from hot blue stars in that nursery. It's about 24 light years across this vast stellar nursery, and it's about 1,000 light years from us. So next time you spot Orion, like Gavin said, look just under the 3 stars that make Orion's belt for that fuzzy patch in the night sky. New stars are being born right there. We're going to go ahead and take a trip now to our own sun. In stellar nurseries, gravity pulls together those clouds of gas and dust, like you said. Things start to heat up. They start spinning, they become a ball, and when they're hot enough, they can release energy through nuclear fusion and shine as a star. That's when hydrogen is fusing together to make helium in the core of that sun. Like our own sun right here, which is a yellow dwarf star. Once that star is formed, it's what we call a main sequence star, and it could be in this stage of its life for millions, maybe even billions of years. Our own sun is about halfway through its main sequence of its evolution. So we've still got a few more billion years of the sun shining at its current size. But we can also take a look at the future of our sun as well. To do that, we're going to land back on Earth and find something else in the night sky to point the way.
We're going to take a look at Taurus the Bull. This constellation in mythology represents Zeus when he turned into a bull to retrieve a princess. By Taurus, we have the Pleiades box, which is a what is it, Mike?
That's our open star cluster. So when you go outside tonight, you can probably see in your screen the 3 stars that make Orion's belt. If you just hang a right, you'll find the horns of Taurus, and you might see a dot there. That's a bright red giant Aldebaran. We'll talk about that more in a minute. But we're going to take a detour to that box that you brought up there. That's the Pleiades. It's sort of in the ear of Taurus the Bull. It's a star cluster. This is a group of stars that are close together, traveling almost as a unit through space. So there are stars like our sun that are traveling solo, but the Pleiades is a star cluster. Now, over time, this open star cluster, the stars will start to move farther away from each other. In a contest of gravity versus velocity, eventually the speed and direction of those stars, they're going to move away from each other. But we wanted to point it out because it's great to look at in the winter sky. Right now, those stars are moving through a patch of interstellar gas and dust, and the light from those stars is causing that dust to glow. So you can see that beautiful frosty blue haze just in time for the winter sky. But while we're looking toward Taurus and the Pleiades, I'd like to go to the eye of Taurus the Bull now. That's our next stop. So yeah, it's a great idea. We're going to go back to the night sky. We're going to zoom us back to Earth and land. So again, there's our view of, you can see Orion's belt, you can see Taurus and the Pleiades just above it. There's a star inside that highlight of the horns of the bull. If you take the 3 stars of Orion's belt, hang a right, you'll find the red eye of the bull, Aldebaran. And let's catch the red eye right now and zoom into Aldebaran. This is a red giant. It's about 65 light years away from us. And I point it out because it's about 44 times the diameter of our sun. 44 times the diameter of our sun. It's staggeringly big. So when you have a main sequence star that gets to be a senior star, there are changes. The hydrogen gets used up in the core of that star, changing to helium. The nuclear reaction in the middle will stop, and that middle will start to shrink. But then the outer layer actually starts to get bigger as fusion's happening out there. The star can start making a lot more light, sometimes 10,000 times as much light, but over a vastly larger area. The star gets much bigger, the temperature drops, and we often think of red as meaning hot, but a red giant is actually cooler on the surface than our own sun would be. So that's the next stage in evolution for a star like our sun. It would eventually expand to become a red giant. And eventually, a red giant will stop burning altogether. And a few different things can happen then. So to find out what might happen next, we're going to land back on Earth. And we're going to look now, we're going to face south. We've highlighted a constellation called Aquarius. We're at about 5 p.m., so we just advanced time a little more here so you could see it there in our southern sky. It's one of the zodiac constellations. And for a moment, we just circled another deep sky object that you can see near the constellation Aquarius. It's a nebula. Now, earlier we saw a nebula where stars are born, but this is a whole different kind of nebula.
This nebula is a helix nebula. It's called a planetary nebula. And it's actually called a planetary nebula because the early astronomers in the 18th century thought it was a planet. Mike mentioned the red giant, or the red dwarf star, and how it's after it ran out of hydrogen, it would start pushing outwards. Well, one thing that can happen is that it can turn into a white dwarf star. Right in the middle of this planetary nebula, the Helix Nebula, there is a white dwarf star. Now, it's pretty difficult to see, but a white dwarf star is a star that has used all of its nuclear fuel. So what happens is it pushes all of its gas and dust out around it and creates all these colors, and it stays in the middle with the mass that it has left.
Yeah, so these red giants, eventually they can explode, shed their outer layers. We see all these beautiful gases, but what's left is that very small white dwarf star. That might be about as big as Earth, but it's extremely dense. Take a teaspoon of that, and it would weigh as much as several elephants here on Earth. Now, what happens if you have an even bigger red giant? You get an even bigger supernova, and what's left over could be even more compact, more insanely dense. You could make a neutron star. You wouldn't even have electrons around those atoms. Gravity would pull all that stuff together, and you get a neutron star. But if you have an extremely big supernova, you could actually get a black hole left over, a stellar mass black hole, basically the remnant of a star. So protons, neutrons, not even light itself would escape that black hole. Lots of different things can happen after a supernova. We're going to end our program today by exploring a black hole. To do that, we're going to highlight the constellation Sagittarius. It's more typically visible in our summer sky, facing south. And you may have seen before the light came up there from our own sun, a bit of a teapot shape in the night sky. If you look for a teapot,
well,
looks like we're... Oh, there we go.
I'm struggling a little. It's a little off to the side right now.
Well, that's all right. Let's actually change the month. We're in December. Let's go back in time to the summer. There we go. All right. We've got a lot of power over the universe right here. So we can bring the constellation Sagittarius right into view. Sagittarius was an archer, but I tend to see a teapot shape. You can see it either the archer pulling back his bow and arrow or a teapot pouring out the steam of the Milky Way. When you look to Sagittarius, you're looking toward the center of our Milky Way galaxy. Now, I point that out because we're going to find a black hole there, but not the kind of black hole that's left over from a dying star. There are actually a number of different types of black holes. You can make black holes at the end of a star's life cycle. They're stellar mass black holes. If you have a star collapsing maybe more than triple the mass of the sun, you can make a black hole like that. But we're going to find something different, something much bigger. This is a super massive black hole. It's called Sagittarius A star. And it's because it's in the direction of the constellation Sagittarius. When you look out to Sagittarius in the night sky, you're looking back toward the center of the Milky Way, and in the center of our galaxy is this super massive black hole. Now, there are some theories out there as to how these form. They might form from a runaway chain of colliding black holes and stars. These are on a whole nother scale than stellar mass black holes. These can be millions, even billions of times more massive than the sun. This giant is about 4 million times the mass of the sun.
As you can see, there's like a disk around the black hole here, and this disk is made of gas, plasma, and dust that is gathered around it in space. As Mike mentioned, this black hole has a massive amount of mass. It is actually also very large. It's about 14.6 million miles in diameter, which is extremely difficult to imagine. We call it Sagittarius A star because it is located, when we're looking at deep space objects, usually we use constellations to name things, just like how we looked at the Orion Nebula. If it's in the direction of the constellation, we typically use the constellation's name in front of it to name it.
Yeah, and that's why we thought we'd use the constellations as reference points to guide us through our show today. Now, as Gavin's flying us, you can see an effect known as gravitational lensing in action. You can actually see the light bending around the black hole. It has so much gravity it can actually bend light. We can look at objects beyond that black hole, and as the light is bent around them and distorted, we can actually see things beyond that black hole, but we might see 2 or 3 of the same object. It might really just be one object out there in deep space, but the light has been bent. And sometimes when we look to Hubble images and we're looking out into space, even as we're looking at faraway galaxies in those photos, you might see 2 or 3 of the same galaxy because of gravitational lensing from other objects closer. So it's kind of exciting as we move around here to see that gravitational lensing. Take a look and see how the light is actually being curved and bent in its trajectory around the black hole. And so that brings us to the end of our tour today. We hope you gave you some food for thought, some exciting things you can find. Head outside and enjoy the winter sky, which is starting to rise. Look for Orion, Taurus, and the Pleiades, and see what you can find. Come see us on site here at the Buhl Planetarium at Carnegie Science Center. Join us for one of our daily Stars Over Pittsburgh shows. We'd be happy to have you. My name's Mike, and Gavin, thank you so much for joining us for our past Bite-sized Buhls. Excellent work.
Thank you.
All right. Thank you all. Have a great evening and keep looking up.